Okay, thank you very much. I'd first like to thank all the sponsors for this opportunity. I mean, this really is a wonderful opportunity to get in a single room, gather all the people interested in this particular topic. As Mr. Leong said earlier here, DNS is one of those protocols that is often overlooked and is, however, underlies everything in the internet and so much of what we do today. And so it is very important to actually understand it and understand how it involves, how we can improve the security on it. There's so many, even today, every time you open up an account or you do anything on the internet, there's this assumption and just dependence on DNS that many of us aren't aware of. And we've been depending on it for all these years. And you know, thanks to Dan Kaminsky and others who discovered vulnerabilities recently, we're now realizing that we have to fix this. But hopefully what I'll leave you with at the end of my talk is that we're going to, I think we'll end up further ahead than where we started if DNSSEC gets fully deployed. Now before I start my talk though, however, Steve Crocker, I don't know how many of you know Steve Crocker, but he wrote the first RFC, the first standard for the internet back many years ago. He's also the chairman of the board for ICANN. But Steve's someone who's just been around this business for a long time and is very much, you know, the term invented the internet is used way too often, but if you were going to include a small handful of people in that circle that you could say invented the internet, Steve is one of those people that is really close to that. So he is kind enough to have done a short little video for us. I'd like to play that for you. I know that sounds like kind of corny, but I think sometimes you want to attach a face to the name and understand this. I think it'd be useful. Where is it?
So here we are, 8 o'clock Tuesday night in Washington. I'm stuck in my office. I wish I were there with you guys. Steve Hooter has arranged another special DNSSEC session with all of you. I'm absolutely delighted. Wish I were there. I appreciate and applaud the Internet Society of Hong Kong, or actually I suppose it's the Hong Kong chapter of the Internet Society, and the Hong Kong Registry for sponsoring this session. And I hope that I see evidence of a lot of sign zones in all of your domains. Have a great time.
All right. So let me close him up here. Being chairman of the board of ICANN, yeah, he is one of the key people that have spearheaded the effort to get DNSSEC deployed widely and responsibly. All right. So now I'm going to start my part of the presentation. And if there are any questions, you know, people are going to just ask questions. Just stop me, all right? Because I might start going on because I like Steve, am very excited about this stuff, so I might get a little too excited. First of all, a little about me. I work at ICANN. I'm responsible for their DNSSEC policy, processes, architecture, all that. In particular, I was responsible for designing both the policy and the technical design for the root DNSSEC deployment. And I'll drop into what DNSSEC is here in a minute. Before that, I had a couple startups, sold the last one to Microsoft, and then I actually worked in the U.S. government for a while. And for many of you engineers, I tell you, working in the policy environment, you know, I quit after 4 years. I couldn't handle it. The bureaucracy was just stifling. But it really opens your eyes, and you see the truth, and you see what's possible, what's not possible. You see that things are, like everything else, it's not black and white. You see that things aren't as bad as they should be. They're not perfect either, but quite an exciting thing. And then finally, I ended up working for ICANN and doing some of this stuff. So I'm really an engineer at heart. So, all right. Let's see. There you go. All right. I'm going to start right off the bat with an example of what DNSSEC is, only because I think we have a wide range of people in this audience. For some of you, I apologize for the, you know, this is something that you may already know. But oftentimes I'm asked, why are we working on the DNS? It ain't broke. It seems to work just fine. We had that very high-profile discovery by Dan Kaminsky, which alluded to the problems that we could have on the DNS. So I'm going to describe that attack kind of at a top level just so you understand. So what's the problem DNSSEC is trying to solve? Okay, it's called DNS cache poisoning attack. So normally what you would do, I have some pictures there of what your ISP, usually your ISP or your enterprise, or possibly even your end node, has a resolver, has a DNS resolver. This is the thing that actually goes out to the net and answers your question. So typically you would ask that, typically at your ISP, you'd ask, what is the IP address? Where's the web server? What's the IP address for www.majorbank.se? And I'm just picking Sweden because they were one of the early DNSSEC adopters. You'd ask this question. Your resolver then goes out through a number of queries, eventually asks the server, the DNS server at the bank, or that the bank is responsible for. And normally it would come back and give you the IP address, and you'd be done. What the cache poisoning attack does is, though, you have an attacker that understands that maybe this bank site is a popular site and there are a lot of requests for it. So instead responds with an IP address for their own web server, a rogue web server, an attacking web server. And if this is done carefully and done in a way where you could actually get the DNS resolver to accept that response, which is what Dan Kaninsky showed could be done initially within hours, and then people found various ways to do this within minutes. That was really scary. So, but if this happens, then of course the resolver says, fine, I got an answer. I'm happy with that. It returns the IP address of the bad web server. The right answer eventually comes back from the slow DNS server at the enterprise. Doesn't care. Resolver doesn't care. I have an address already. Ignores the second one. So then you as a user go to what you think is your web page, your bank's web page. You say, get page. Comes back. The attacker's page has something that looks just like the bank, oddly enough. Okay? They've scraped the website of the bank and they make it look just like it. And as we'll see later, there are much interesting ways to do this. So you get a login page. You come back, you send your username and password. And usually what happens in these attacks, the attacking web server just comes back and says, well, I don't care about the rest of you. I'm not going to help you process your bank transaction. I don't care. I just wanted your username and password. So they store their username and password. And away we go. So, all right, so that's one attack. But since you've poisoned DNS resolvers in order to optimize, make the experience of the customer, have the customer experience being very positive, they remember answers. So this is the cache, the DNS cache in the resolver now actually remembers that last answer. So the next time someone comes over here, not just you, some other user goes to their bank and says, what's the IP address for my bank? They also get the wrong address. And the same thing happens, okay? And so the bad guy continues to collect that, information like this. So what does DNSSEC do? DNS, at this point, the legacy DNS has no cryptographic protection. In other words, it's everything. All the requests are, not only are they in the clear, but there's no comprehensive way to check to see if responses have been modified or not. So what DNSSEC does is add some cryptography. It digitally signs, and this is something that I may talk about a little later, but digitally signs responses. So request goes to the DNS resolver like before. Request goes to your bank's, eventually to your bank's DNS server and comes back, and the DNS server comes back and tries to give you the right answer. However, in the interim, the attacker is sitting there still trying to get you to go to their web page so they can collect account information. However, since the DNS resolver now has DNSSEC and is doing validation, it's actually doing a cryptographic check on the digital signature to see if any modifications have happened. That response is just dropped and ignored. The correct response comes eventually from the DNS server at your enterprise or at the bank, and that hits the resolver. The resolver remembers this. The right answer comes out, and everything works the way it should. And of course, since it's a caching resolver, the right answer is now remembered in that resolver for good, or for the length of the cache timeout. So now requests go, everything is working fine. So that's basically how DNSSEC works. So let me get a show of hands. How much of that was review for everyone in here? How many people already knew that's how DNSSEC worked? Okay, good, good. Not what I figured. All right. Okay. So let's see. All right. So that first slide I skipped over, all I was saying is, you know, there's, we've been very lucky. There's been a lot of DNSSEC deployment going on there. I mean, people have embraced this a lot because of the Kaminsky attack and things that earlier that were discussed by Mr. Leong. And people are motivated by this. The ones that, you know, governments are motivated by this, you know, people that operate internet infrastructure, DNS, the internals are motivated by this. So there is a lot of deployment going on. There's plenty of other motivation, though, as well. Just last winter, there were a couple very high-profile incidents that were published where DNS redirection was one of the modes of attack. There's other stuff going on as well. There's this whole idea that we can use this now secure infrastructure database. DNS is just a big, large, distributed database, globally distributed database. We could use this for other things. This has got a lot of us engineers really excited. You know, this is what really keeps us going. So there actually is a group in the IETF, which is the standards organization, old-time standards organization for the internet, for which Steve Crocker wrote the first standard. There's a group there called DANE. I don't remember exactly what it stands for, but they're working on standards to actually use the DNS to distribute either certificate information, digital certificates when you go to a secure website, the little lock that shows up on the bottom, or to validate them as well. And there's other work as well saying, okay, well, why, you know, we got this globally secure distribution mechanism. Why don't we distribute other things as well? And then the list actually is going on and on and on here. I mean, there are other things, you know, that more of us might use, but things like SSH, management tools. We can secure management tools by using the DNS as well. The key thing here is if I know you and you know me, we can exchange keys, and that's no problem. But by being able to put stuff like this in the DNS, I can gain secure ways of communicating with you even if I don't have a personal relationship with you. I mean, I can count on the third party, and the third party becomes this community trusted, globally trusted network or system infrastructure, the DNS. A few other interesting things have been popping up though recently. People are thinking digital identities. I don't know what the efforts are in China or in Hong Kong, but I know a lot of countries, the U.S. is way behind on this, like we are in a lot of things. But you know, trying to have digital IDs. There's a lot of interest in digital identification for cybersecurity, for government services, for a whole host of other reasons. It's actually a good idea if done right. But you know, there may be ways here to be able to interface stuff. If I have an ID from the Aadhaar ID system in India, I may be able to use this across borders. Why not have some way to do this? And so people are excited and dreaming about ways to maybe interface these things across borders. Other things that I've heard that are very interesting is why not just send little, right now I return an IP address in the DNS, among other things. Why not return a digital signature for a piece of software? I run, you know, my website is abc.com, and I sell ABC software. Why don't I use the DNS actually to transport configuration data for my products securely? You know, the internet might become the way it was 20 years ago when we could trust it. It was a small community, guys, but we could actually start to turn the tide on some of the cybersecurity problems that we're having. And another thing that's interesting, and this is off of ISOC's own DNSSEC effort. They have an effort called something 360, but I think it's an IPv6 and a DNSSEC effort, awareness effort. And so ISOC is very heavily involved in trying to expand both IPv6, as you guys know, with the IPv6 World IPv6 Day, but also DNSSEC. But there's a whole bunch of people out there saying, you know, we could really optimize the power system, power distribution, by relying on the internet as well. Scary thought to me. I mean, oh my God, I would never trust the power system to the internet. I mean, someone could blow something up that way. Well, yes, true. That's why they're looking at things like this, and actually there are companies that are looking specifically at how do we use DNSSEC to secure some of those things, not just reading your meter, but being able to I think the long-term goal for these power, for the smart grid stuff is if you had power to give back, not just to take from the outlet, how could this be done automatically and seamlessly? Scary stuff, but these people are looking at it as well. All right, enough on that. There. Okay, so one of the things I said last year, there are a couple cases there. I mean, it's very hard to convince people to deploy new technology if things are working. So these are I won't say they're good, but they're useful cases when we go to either our managers or to even convince ourselves that it's worth spending the energy to build a DNSSEC signer and develop things. So DNS Changer, that's what it was called. This was a big deal. There are about 100 countries involved, many machines involved. This was a scam where you visited a rogue website and it actually replaced the IP addresses you ask. So in that earlier picture, you ask your ISP's resolver to tell you what the IP address is for your bank. This was an attack where you'd ask they would replace who you asked, and they pointed to themselves. And so that way, and it was insidious. It wasn't that they were just trying to collect your username as passwords. All they really wanted to do was get you to go to their websites and click on or see their ads. So anyway, it's still just as evil, okay, just as evil. So in a world where DNSSEC was deployed or validation actually happened on your laptop, if Windows, for example, would just put the validation effort in your laptop, end-to-end security using DNSSEC, this problem would be solved. This couldn't have been done because the signatures wouldn't have validated. This guy is intercepting and trying to send you to their own website. Well, they don't have the key material or can generate the right digital signatures, so their stuff is just going to fail. So it would have solved this problem. It would have avoided this problem, sorry. There was also around the same time, these were funny, they both happened around November last year. Brazilian ISP, this was an internal attack where they actually got people to go to another website that looked like Google, but they actually had you download viruses doing that. You know, a little box like that pops up. Most of us in this room are smart enough not to click on that, but you know, my mom might not be. So this was a pretty bad situation. I know you can't see the links on the bottom of these things, but I put them there just for reference. All these slides, by the way, it's a PowerPoint slide deck. You can take them, you can reuse them, you can do whatever you want with them. I don't care. There's no copyright on this. But there's a link on the bottom. This was a presentation made by Google, and it described the various hijacks that have done to their websites over the years. Very interesting. I mean, it's amazing. I mean, there's an awful lot of TLDs or top-level domain registries, places in very unsophisticated countries where, you know, the controls, the processes weren't that secure, and people had completely redirect people to totally different sites. Some of them just strange stuff. But this is a good presentation because it shows you all these examples since 2009. So it's kind of useful. So there's plenty of motivation. I feel there's plenty of motivation for DNSSEC. So also there's some governments like Sweden and Brazil have actually work alongside .br, which would be Brazil, .se, top level domain, the operators of those guys, to encourage DNSSEC deployment. In Sweden, I think if it's got DNSSEC, it's cheaper to register than it is if it doesn't. Things like that. But also they've encouraged things like banks, other financial institutions to deploy DNSSEC. Says, this is something we want you to do. And then just this year, I mean, I'm always amazed when, because I worked inside the system and I understand how slow bureaucracy can be, I'm always amazed when I see progress. So, in March of this year, our Ministry of Communications, the FCC, came up with a list. We can never command, we can only suggest and make recommendations. So, so there was a recommendation to combat cybersecurity. And there were three main points in this recommendation. One is go after botnets. One is secure the routing infrastructure, and one was DNSSEC. A lot of that work actually was done by Steve, so, the guy in the beginning. But so they come up with these recommendations, and I figured all the industry, the ISPs, those are ISPs I have. They're AT&T, Century, like these are our 7 biggest ISPs. I figured they'd all say, you know, fine, see you. A nice idea, but we're not going to do it. No, they came right back and said, yeah, okay, all right, we're committed to do this. We will support DNSSEC. So, you know, and one of those guys, Comcast, our cable provider, absolutely has done it and has, and I have more links down there again if you're interested, that actually they published their lessons learned and how hard it was to do this and how easy it was to do this. And you know, I recommend any of you that have, you know, that are thinking of doing this or approach me later and I'll give you the link directly to look at what others have done and what problems they may have seen and what they think. We also had a U.S. government mandate in 2008 that said, you know, everything under .gov should be DNSSEC signed. Yeah, right. That took longer than expected. But 60% of it is signed. So that's good. All right. And this is, you know, this is the, to me, is the most exciting slide, is that we never knew this was going to happen. In fact, Vint Cerf, the other, you know, father of the internet, actually, more people actually call him the father of the internet, but Vint Cerf was involved with some of the DNSSEC effort for us early on. And we're very lucky to have somebody with such stature. Also, you know, gray beard, about the same age as Steve. Anyway, so he's helping us do this stuff, deploy DNSSEC, and he's participating in one of the events. And he comes out of that thing and he goes, you know, more has happened. More is happening with DNSSEC than you see. On the surface, you think, okay, we've secured the DNS. There's this problem with DNS redirection. Dan Kaminsky's found this thing. And so we're solving that problem. Like good engineers, we're follow the standards, we do the right thing. But we end up now with this global PKI. We have a database, as I said early on, a global secure database. So this, usually if you try to build something like this with governments, and you go to different governments, believe me, I was a part of the passport effort. You know, your passports have chips in there. You try to go to another country and you say, look, you know, why don't we come up with one key and we'll all trust this key and we'll secure things that way. Well, who's going to have that key? I'm not, you know, I'm not going to be under your key. No, you're not, there's approaching things top down doesn't always work. In fact, it usually doesn't. It usually doesn't. And so the nice thing about DNSSEC was this is us. This is our community. This is us engineers. We go to these standards meetings, and we all together over the course of, DNSSEC is not a young protocol. It's been worked on for at least 15 years, maybe 20. But over the course of years, you know, we all said this is a problem. Let's solve it. And so from the bottom up, we've tried to come up with these protocols, tried them, and finally we created this system, and it was all bottom up. We didn't go to governments and said, well, how do we do this? You know better than us. You'll design it. Yeah, right. You know, governments never know better than the engineers. So the engineers, we came together and built this thing. And now all of a sudden we have a single system. And there's so much opportunity here. You know, new products. I mean, if you're an entrepreneur and you want to come up with new, there's so many security products that come here. So that's what this picture is. There are two things. And the one other thing this is illustrating is CA certificate roots. That lock is supposed to look like the lock you see when you hit a secure website. So that's a good business. I mean, it's been around for a long time. They take on responsibility and they build trust in the internet. I mean, you would not go to a bank site unless you saw that lock there. But there are almost 1,500 of them out there right now. And so what we've run into is problems with trust. I'm not saying one is better than the other. I think you can never say that on the internet and about security. Security is there's no one solution to security. There's no one bullet. But they have 1,500 different certificate providers. So if I'm IBM, I buy my certificate from, I don't know, VeriSign. So I go to one company and I buy my certificate. Well, I could also go to Rick's CA service, which, you know, I have to pay money to get audited. I have to go through a process. But I could go there and also get a certificate for IBM.com. They both validate. and they both will not show a flag, no error messages on my browser. So as far as the end user is concerned, they're the same. This was a problem last year, maybe year before last, with some certificate provider which had a slightly lax policies. And so what happened is Google got kind kind of slammed here with this. So it's kind of a, it's a problem with too much success. So, but with DNSSEC, there's only one root. There's only one set of TLDs. If, .hk, for example, there's only one TLD. So you only have, you have a much more constrained space. And so I think together you can come up with all kinds of solutions here. And so this is motivates me to go quit my job and go, work on a new product and build it on this new infrastructure that's happening. So, all right, going on to it. So where we are today, yeah, this is a busy slide, but so there are 315 top-level domains, .uk, .hk, .se, like that, .com. There are 315 of them out there. 92 of them have DNSSEC deployed on them, and every day there's more people deploying on them. So this is good, and it's even deployed on some of those IDNs there. I mean, .asia was one of the early ones here, which I'm really impressed. Most recently, .post. That'll be interesting to see what the universal, whatever, union, postal union, the International Postal Union is going to do with that. DNSSEC signed on .post. Interesting idea, right? Maybe send certified letters using with DNSSEC and certificates. Who knows? Might be all kinds of stuff going on there. One of the critical pieces in this whole picture, I don't like talking about it because it's it's something I was working on, so I don't want to sound not humble. But the root sign. So we did, because we're a bunch of engineers and because politics is not what we care about first, we have a root sign, a single key. It's managed by 21 people from around the world. We have somebody from CNNIC, we got somebody from .ru, we got someone from Brazil as well. But the 21 people, 18 of them are not Americans. I'm supposed to say not Americans, which is a cool thing. So we need 3 people out of that group 4 times a year, so we rotate them, to continue getting the root signed. ICANN itself cannot do this. So no one can do this alone. We have to have these people show up. So we usually invite more than 3. We invite 4 or 5 in case one of them doesn't make it or there's a problem, right? So we do this key ceremony. That's what it's called. It's called a key ceremony, 4 times a year. But because we have these 21 people from around the world, and they're engineers like us, we can trust this. This is our own creation. This is our baby, all right? So anyway, so the root sign, and we have it audited. We pay for a very expensive audit by one of the big 4 auditing firms, because the internet is not just for us anymore. It used to be just for us geeks. It's not for us. We need the financial community and the business community to also trust what we've done, and they rely on it. So we have to go do something real. However, about 84%, since .com, .de, a couple really large domains assigned, about 84% of the domain names out there could have DNSSEC deployed on them. ISPs are happy. There's plenty of software out there, that supports this. Unbound, bind, if you're DNS people at all, you'll know that those are very common products. They all support DNSSEC, have DNSSEC built in them. So this is all great. So why am I here? We're done, right? DNSSEC is done. But the problem is, at the next level, at google.com, or at IBM.com, or Intel.com, or I don't know why I'm picking .coms, I'm sorry, but whatever. At the next level, less than 1%, there are over 200 million domain names out there total, including all the junky ones we buy because we think they're cool. But there are 200 million of these names out there. Less than 1% of them have DNSSEC deployed on them. And if it's not deployed on your domain name, it's not secure. I mean, there's no benefit here. I mean, we have to validate these signatures. The digital signatures have to start at the domain name. So a few guys have moved forward on this. Is great. And things like DNS Changer that happened last year in November, and a bunch of other attacks. Yeah, clearly there's a reason that we need to do this. And then there's this whole future. Cool new startups we can do, and security solutions that actually can then help the end user go back to being able to trust the internet and download stuff. I don't get it. So what's the problem? Well, this is one of the reasons, and I'd love to chat with some of you guys to see what you think, what kind of barriers or what you hear from people on the street, from the people you deal with from IT departments. Why aren't they doing this? Do they even know what DNSSEC is? I know a lot of them don't. my experience was I talked to a bunch of Fortune 500 CIOs, and is that they know what DNSSEC is, but they're so busy trying to take care of the fact that everyone's bringing their own laptop into work, or there's all these other attacks going on. They have so many other fires going on that this is kind of hard. The other reason I've seen is and this is partially our fault, meaning engineers' fault, the people that work on DNS and some of the software, is there are very few really easy solutions for this. DNS before was set and forget. You create a zone. You'd say, here's the IP address for this bank, this whatever, domain name, and you can leave it like that. With DNSSEC, the signatures actually have expiry times. So not only do you have to deal with crypto stuff, keys, crypto, that's another thing, very scary to people, but you have to now worry about, well, if I don't update the signature on this thing in a few months, it's going to expire and things are going to fail. So, and then there's a chicken and egg problem. So if you finally, after I've taken the guy out to drinks and I've convinced him, says, your company really has to deploy DNSSEC. So the next day he comes in, he calls up his registrar and he says, all right, I would like DNSSEC. The registrar goes, what? What's DNSSEC? And then if he knows what it is, he says, well, no one wants that. No one wants that. No, that's why we don't support it. We don't have it. And then now the guy's like stuck again. Because for the vast majority of small, medium-sized companies, they're going to want a third party, either the ISP, their hosting provider. They want someone else to take care of this DNSSEC thing. I think if you're a bank or anything large, you're going to do this yourself. But if you're so the registrars have to be on board with this. They have to, at minimum, know what it is. But there's a chicken and egg thing. And when I talk to the registrars, they say the same thing. Look, no one's asking for this. Well, no one's asking for this because when they ask you, you say you don't support it. So anyway, sound familiar? It's a little bit like IPv6. So anyway. So I don't know. I mean, I can go through this quick. Yeah, this is the same stuff. One of the things we can do as engineers is the deployment part. How do we make this easy to deploy? And how do we make it so that if we do deploy DNSSEC, or we get someone to deploy DNSSEC, at first, how do we take the fear, uncertainty, and doubt? That's what food is. It's a very common thing that we like using in the U.S. Food: fear, uncertainty, and doubt. How do we take that out? We have to make it simple for them. We either have to get them to be able to outsource it or come up with some sort of package. And it's not hard to do some of this stuff. Some of the stuff we'll be talking about in the workshops to actually make this happen and make it happen in an easy way. But not only that, we have to do it in a trustworthy way. I mean, we're talking about maybe actually having digital certificates to your bank, the thing that actually verifies your bank, being dependent on some of this stuff. So if it's done, it should be done in the best way. And we'll have a discussion, I think, at the end of this, where you stand on that. But you need to determine who your customer is and what their risks are and what they care about. So the rest of the slides, I'll go through pretty quick. They're just going to be how you go about deploying something like this in a secure way and try to remove some of that fear, uncertainty, and doubt. So I mean, all right. So if there's one slide you walk away with this from, you say, what can I do? Let's say for a minute I've convinced you DNSSEC is a cool thing and you want to do it. All right. So you want to raise awareness of DNSSEC. When you're talking to your other IT friends or something, have you heard of this stuff? What do you think about it? Just talk about it. And then try to get people to start deploying this on their own domain names. It's really sad that it's not deployed on more domain names. It's not hard. And some of the feedback I've gotten from the companies that have deployed it is that their customers are starting to ask about security. They used to only care about bandwidth and speed, okay? And that's great. Most of us still want bandwidth and speed. We want the fastest internet connection in the world. But now they're actually, he said that now they're starting to ask about security. So although DNSSEC does not solve everything, it's another security feature. It's another thing that you could sell or say, look, we're better than those guys because we actually have DNSSEC turned on our domain name. So, there's some positive. The other things I've heard from the people that have deployed this, that starting early is better than starting later in starting this deployment effort. I mean, there's kind of a good thing because DNSSEC is not deployed everywhere at this point. If you fail, you're probably okay. If the signatures expire, you're probably going to be okay. So at this stage, it's easier to get your feet wet and actually learn this stuff and deploy it right. Whereas later on, once once this is fully deployed, either, like in the U.S., government just for government agencies, but mandates or whatever, once it's fully deployed, it's going to be harder to experiment. And for ISPs, yeah, this slide deck was aimed at some ISPs. At minimum, one of the things you want to do is make sure your network actually fully, doesn't truncate the extra packets, the extra fields that DNSSEC needs in order to validate things. And that's not a very large requirement. Many ISPs don't have a problem with this. I mean, I'm not saying that, as long as they can pass the packets intact, I think that's a good thing. So, all right. So, all right. Well, let's make a transfer. Let's skip that slide. All right. So getting the hardware. There are a lot of people that offer wonderful courses. I'm thinking of the NSRC guys here and my colleagues, Phil and Hervey, but offer many ways to how you go about making the machinery of DNSSEC work. One of the things that we have not found anywhere, because it's kind of a black art, it is secretive. Companies tend not to tell you how their security systems work. They tend not to tell you, how many layers of concrete or how many layers of, how their rooms are secured. Taking that machinery and operating it in a good security, using good security practices, is something that is hard to find. But because for the root, we're the, ICANN, we're open, we publish it all. It's all free. Nothing is hiding. We show everyone how to do this. The place where we can learn a lot of this stuff, if you have a friend that works at a certificate authority, they've done this. This is what they've been doing for a living. This is how they make their money for decades. That's the good thing you can learn from them. They've screwed up recently, but that doesn't mean they're not valuable. Someone who's made a mistake is actually very useful, okay, because they know what the mistakes are. So if you know anyone that does, certificate authorities, chat with them. If not, talk to us, right? So it can be really fancy. This is what we have at the root, at the very top. Very secure, highly secure thing. We have a biometric, eye-scan reader. You got to do this, and it tells you when your eye is just right, and if your eye matches, it opens the door. It's a pain in the ass. We really don't like using this. But it's an LG. It's a standard product. You'll see this everywhere. Everyone in the world uses this particular model. And then we have a couple of safes. These are, they don't have, it's all up to your risk profile. You certainly don't need safes like this. These are, $15,000 a piece safes. They're top, rated for top secret. And I'll tell you guys a secret about top secret safes. So U.S. government top secret safe. I only picked them because I didn't have any reference point. Okay, and we want to do this right, and we want people to trust it, right? So we want to do the best we can. That's a safe at a grocery store is stronger than these safes. Okay, safer meaning the one at a grocery store takes probably an hour to drill through to open up to take the cash out of. These safes, and these are the safes that the U.S. government uses. Anyone can buy them. Top secret rated safes. It takes like about 20 minutes to drill through one of these things. Okay, but it takes 20 hours to be able to get into that safe and out of that safe without detection. This is something that if you go to the workshop, we'll explain. It's your risk profile. Early on, we said, we're ICANN, we don't have an army, we don't have armed guards. If someone breaks into our facility, knocks some people's heads over, and steals stuff, no one's expecting us to survive that. We're not, that's, but we do want to be able to detect a compromise. If there's any chance, we want to be able to detect it. So that was really, really important. Evidently, it's really important to our government as well. So because the 20 hours to be able to get in there, surreptitious entry, that rating you won't see on a grocery store safe. Because if you go to a grocery store, you break in a safe, you take the money, you run. So you don't care. That's that. And then this is a crypto device where the keys are generated and the keys are stored. I think actually one of the vendors is here. But and we're not picking any one vendor, but we happen to use this one because it's a really good product. It's rated at a very high level, so that higher than any other cryptographic box levels, that if someone tries to take the keys out of it, any one of a number of different ways, it deletes everything. So it doesn't blow up and make any smoke. That would be cool. It'd be great if you guys put smoke in it, but it doesn't do that. It just deletes everything. Yeah. So, but but so there are different levels of security, and that's something called level 4. But that's, that's a U.S. certification. It's, it's not, you guys use whatever certification. And the Brazilians, for example, they have their own certification profiles. They don't rely on, these profiles. But there are different levels. And there's some other cards there as well. I think this one's used for .com, and there are others. This one's used for .New Zealand, .UK. All right, sorry, I'm probably running over. But it doesn't have to be that expensive. Sweden, for the longest time, just did this and this, a smart card. A smart card has got an amazing amount of technology in it. These things are certified to all kinds of levels. Well, not the highest self-destruct level, but they're certified to really high levels. And they can store keys. They're just as secure. And if you have the right process around that, i.e. no one person has full access to everything, that's really one of the fundamental tenets, this will work too. It's slow. It does 1 signature per second, where the other boxes will do, I don't know, a couple thousand. But maybe that's good enough, 1 signature per second. So you could do that. And then store the stuff. And I know another group that does this, another TLD that actually uses a safe deposit box. They store stuff. So they don't even want to manage the safe. So they have a whole process where the manager has the key to the safe, and and the engineer has the PIN code, and there's a split control. And then I have something here called a TPM. Many laptops and many servers actually have a crypto chip built in them, and I understand anybody can get this. It's something actually used to secure the box itself, but it's there. It's called a TPM chip. There are drivers for it. Go for it. We recently did this for Costa Rica. Costa Rica in March deployed DNSSEC on .CR using that TPM chip. We helped them do that. So that's pretty cool. And I think they're going to try to get a couple other Latin American countries to do that. Well, I'll skip this. I mean, there's a demo of how their particular system works, but you can grab that anytime you want. Or it could even be this. You don't have to have all this, crypto and special equipment. If you do things in a careful way and it's transparent, it's documented, this is all software keys. Okay? But just carefully separated. There's an offline machine to generate the keys and to do certain operations. There's your off-net, meaning behind a really good firewall, machine that's actually doing some zone signing as well. So that would work as well. So it doesn't have to be expensive. It doesn't have to be complicated. You just have to think about it. That's all. These are the few things they all must have, though. We've learned there should be, because you are in some ways trying to convince your public or whoever depends on you to trust you. Documented procedures. That may sound like something awful to most of us engineers. Write something up. Oh, God, I hate doing that. It just takes forever. And it is awful. But the Swedes, bless their heart, they publish theirs completely. It's not open source. It's equivalent to open source for documents, Creative Commons. You can just take their stuff and modify it. And an important thing about that is it makes you think about security, about a different way. Most of us engineers don't think the way you have to do this sort of security stuff. This forces you to do that. Oops, sorry. Multi-person access, no one person. I mean, you'd be amazed how many places I've gone and said, no, you can't have, you can't have the combination to the safe and the PIN. What do you mean? Don't you trust me? It's not a question of trust. It's a question of the public or whoever your relying party is trusting you. So multi-person access. Sweden just splits it across 2 people. So it doesn't have to be 21 people. It could just be 2. Plenty of audit logs, things that allow you to go back and find out what happened. That can be automated stuff, paper stuff. For the root, it's all paper and handwritten. Monitoring, things that one of the biggest problems you see with DNSSEC, it's not a big deal, but these are lessons that we've learned over the last couple of years, that people forget to do what they have to do and the signatures expire. And they expire, oh my God, all of a sudden, and then, not only is it embarrassing, things stop working sometimes. So you do need something like that, just a website that sits there and checks things. And oddly enough, I know you hear this over and over again, but even today we've had a few cases where someone, not for DNSSEC, but for certificates, did not use a good random number generator. Just using dev random, if you guys know what that is. I mean, that's a pretty good random number generator on your operating system. But if it's on a machine that has no randomness, no entropy, that's sitting in a safe for 5 days, 5 months out of a year, and you go in there every 5 months, it doesn't have a lot of randomness. So, you know, this is something you really should look at. You could use that smart card for random number generator. This is one of the best random number generators. It was a lava lamp with the camera faced at it, and just took the digitized output, and you know, it's called LavaRand, actually. So, oops. But anyway, think about the random number generator thing. Just think about it. It's not hard, and it's not expensive again. And there are hardware things like this too, you know, that are out there. And in fact, there's something called a deterministic random number generator, which sounds weird, but it's great. There's a lot about this is actually something in the U.S. they call, and I pardon the language, cover your ass. And so the idea is if you go through a process and you can document the process and you've shown and proven that you've actually done a sensible job designing this thing, when things go wrong, you're safe. So anyway, learn that in the government too, right? So all right. All right, so this is the end. DNSSEC is it's really going, and I'm really happy about it. But the end user really doesn't know what's going on. You know, in polite cocktail conversation, I see DNSSEC, and they still have no idea what it is, and nor should they. They don't need to know what it is. But it really hasn't. We've hit a little bit of a plateau here, and not able to move because the domain names are not getting signed. So I think in generally just building awareness about this and its value, not only from a new idea point of view, but from securing some of the problems that we have, is very important. And don't reinvent the wheel. Don't be afraid to ask. There are a lot of us out there that have gone through this process, and we're all very happy to share. At ICANN meetings, or ITF meetings, or ask one of us. We have these things. We've gone through it before. We're happy to help you do it, and it's just don't start over. This last picture I like to put because, as I said at the very beginning of my talk here, it's amazing how much we depend on DNS and we don't know it. It's hidden in so many different places. If I get a certificate from a regular company, from a company out to certify my website, they're using the DNS to look up my mail server, to send me mail, to verify I am who I say I am. So indirectly, they're depending on this thing that they shouldn't be depending on. The DNS is not secure without DNSSEC. So there's a lot of weakness there. And all these systems at some point, some place in their path depend on DNS. So I don't know how we got here, but we're here. So let's fix it. Let's make it happen. Anyway, I think that's it for me. Hopefully I haven't put everyone to sleep. I was looking to see if anyone's fallen asleep. Thank you very much.